Actually, our today's topic is the relation between momentum and Newton's second law of motion. But before we get into our discussion, I would like to discuss what does the momentum and Newton's second law of motion actually mean. Now, if we talk about the momentum, then momentum can be defined as the dot product of mass and velocity. For example, here we have a car whose mass is 1000 kg and traveling with a velocity of 5 meter per second. In this case, its momentum will be 5000 kg meter per second. Now, if we talk about the Newton's second law of motion, which is also known as the law of acceleration, then according to this law, when a net force acts on a body, it produces acceleration in the body in the direction of force. The magnitude of this acceleration is directly proportional to the net force applied and inversely proportional to the mass of the body. Now, if you want further explanation of the Newton's second law of motion, then click on this pop-up banner and you will get the video in which Newton's second law of motion is completely explained. Now let's study the definition to understand the relation between momentum and Newton's second law of motion. So, its definition is time rate of change of momentum of a body equals the applied force. Now let's discuss its mathematical derivation. So, its mathematical derivation is consider a body of mass m moving with initial velocity vi. A force F acts on it and its velocity becomes final velocity Vf. Acceleration produced in the body is given by here. The bolded letter shows the vector quantities, means they need direction for their complete description. They are not scalar quantities. So, acceleration A produced in a body is given by A is equal to Vf minus Vi divided by the t. Here, A shows the acceleration, Vf shows the final velocity, Vi shows the initial velocity, and t shows the time. Now, according to Newton's second law of motion, which is also known as the law of acceleration, we got F is equal to ma, where F shows the force, m shows the mass, and a shows the acceleration. Now, rearranging this formula, we got a is equal to F divided by the m. Now, equating the two expressions of acceleration A, we got F divided by m is equal to Vf minus Vi divided by the t. In the next step, we shall have F cross T is equal to mvf minus mvi. Actually, in this step, m is multiplied with the vf minus vi and f is multiplied with the t. So, in this step, we got f cross t is equal to mvf minus mvi. Here, mvf shows the final momentum and mvi shows the initial momentum. Finally, we got F is equal to mvf minus mvi divided by the t. Now let's try to understand this concept with the help of an example. For example, when a fielder catches a ball, he moves his hand backward. He moves his hand backward to increase the time of contact. As you can see in this expression that the time of contact is inversely proportional to the force. So, if the time of contact is increased, then the force is decreased and it becomes easy for him to catch the ball. Otherwise, if he suddenly catches the ball, then the time of contact is very small and he has to apply a lot of force and this may also injure his hand. So, it was our discussion of today. I hope you would have benefited from our discussion. If you have any question, then here is my Instagram ID. Feel free to ask any question now. I will see you in our next discussion. Till that, take care. Allah Hafiz.